So what I talked about today is a little bit about how we ended up building a reactive document editor. So I'll first talk a little bit about the company I work for, Tradeshift, and what we do, and how we're moving to using more interactivity and allowing our users to do multiple things simultaneously while interacting with the documents that they work on. I also give a bit of a demo showing what that looks like, and go a little bit into the source code that makes up some of the components of this new system. First, a little bit about Tradeshift. We are an international platform for business interactions, and what that means is we traditionally grow out of electronic invoicing, helping companies to ship invoices instead of paper around over the internet. But we've since grown into helping out with ordering flows, helping out with what happens after an invoice and payment, tracking shipments around, and even going into financing solutions that we can offer because of the invoicing knowledge that we have. To give you an idea of scale, we have currently about 1 million customers using Tradeshift in all over the world. The documents themselves are mostly made up out of a standard called UBL, the Universal Business Language, which is a fairly humongous piece of XSDs, so XML schemas, that define what an invoice is, what an order is, and what sort of the internationally understood notion of these documents is. Who here has never worked with XML before? Good. Who of you would never like to work with XML anymore? Yeah, okay. But it is what it is, right? I mean, it solves one purpose quite well, and it is to namespace very, very structured data, and these kind of business documents are very structured data. So the XML is actually not really in the way here. I can show you a little bit what an invoice looks like in this format. So there's some generic stuff like an issue date and a business identifier, a note, and there's some stuff further down if we go past the horror, which is where the sending party, which is the supplier here, and the receiving party, which is the customer, and then you got some invoice lines, and you got the general idea. The horror at the top, by the way, is what comes for free if you try and put binary stuff inside of XML, like an attachment with some PDF of payment terms and other stuff that starts to look like this. And that you have to deal with. So our current system is about 10 years old, about as old as the company, because we started out with it. And it's currently pushing about 10 of these documents per second. Document size ranging from a couple of megabytes to hundreds of megabytes. And we're seeing its limits in a couple of different ways. So back a couple of years ago, we made an evaluation. Okay, what are the pain points that we're seeing? And they sort of span two dimensions. One of them is technological in nature. For example, when Tradeshift started out, we looked at UBL and all those complicated tags. You just saw like, okay, an invoice couldn't possibly this complicated. I know an invoice, I get one every month for my phone bill. So let's make it simpler format. We called it portable invoice to sort of get, okay, this is what an invoice really looks like, and all that complicated UBL we'll save for the external API because it's a published standard, so people are bound to get that. Inevitably, you find out that you're wrong, because we started out in Denmark, and we knew the Danish market somewhat, and it turns out that people in Venezuela think about invoices very differently than people in Denmark, and people in China even differently. So there was a point to all the complications in UBL after all. And then there were a couple of side steps along the way into other different formats. But also performance-wise, we had issues. Our traditional backend is a good old Java Spring application with a Postgres database and some queues attached. It kind of works. It still works for the size we're at. We're now at about 7 servers for the backend and 1 Postgres instance on the biggest Amazon server you can buy. That's happily spinning most of the days. But you know, we needed something else. We need to shard out of that solution somewhere. But that was just the technology side of it. We also grew as a company, right? Starting out when I joined, it was about 10 developers. Now we're 1,000-ish. And trying to have 1,000 people contribute to one monolithic backend is a recipe for disaster, as you can imagine. So we needed to find a way to split up these responsibilities around documents and what documents exist and how they interact with each other onto different teams so they can independently work on that. A final challenge that we had is that because we saw some of this coming, we have some nice tenant isolation going on in the database where all of our customers have their own little part of the database. If you send a document from one place to the other, you actually don't really send it. The system makes a copy, and each side of the equation has their own version, their own copy of the document. Even though the content is the same, you could in the old pipeline, you can make a hard distinction and say, well, this is my stuff and this is the other company stuff, which makes sense if you're sending documents and you think about scalability, because then you can shard across those boundaries and create new databases. As it inevitably happens, that's true for documents, but not for all the other stuff. Because in Tradeshift, we really like to say that we're a network, because we are. Like everybody can interact with everybody else. Unfortunately, that means that some of the features of the system do cross those boundaries, because you sort of peek at the other's account and say, do you have these validations enabled, or this kind of special feature hold for you, because then I'll change the user interface a little bit. So that isolation isn't fully upheld. So it means that we have some scalability challenges there as well. But we did want to think up a better way of handling documents that actually embraces those cross-tenant, cross-company interactions a bit more. Some examples that we really wanted to get out is a more interactive ordering process. If I'm trying to order something from one of my suppliers, and you can think about that as a private ordering as well if you're just on Amazon or somewhere else trying to pick out products. But in a business context, you typically want to help your customers a lot more than just throwing something into a catalog. If I'm ordering something and there's some paint or something else, and whoever I'm ordering from happens to be online, why not allow them to be notified of that immediately and allow us to talk to each other and maybe even show them the order that I'm making. Say, okay, yeah, I want to buy this red paint, but we actually have this pink paint, which is really nice on offer. Maybe you want to use that instead. And allowing this kind of interactions allows us, or requires us on a technical level, to be able to communicate between those two companies while a document is still being made. And that doesn't fit with our current pipeline at all, because we have to actually copy it to the other side before they know about each other. Plus, these two companies might not even be in the same part of the world. We have stuff running in Ireland for Europe, we have stuff running in the US for the US, we have stuff running in China for China, but what if a US company is ordering from China? We need to solve those things. So we thought, okay, how can we make a better pipeline that can scale a bit better, where different pieces of functionality can be split up across different systems, and where actually new pieces of functionality can be written not just by us, but by anybody on Tradeshift. So we really try to think, okay, how can we enable third parties to define their own document formats, their own flows, their own editors, and benefit from the actual network of companies that Tradeshift really is. Plus the real-time aspect, and that's what we'll zoom in a bit more on today. So the architecture style that we chose for a new document pipeline is event sourcing. Who of you have never heard about event sourcing before? Cool, then I'll keep it fairly short. What you can do is you upload a document, so any XML containing a valid UBL invoice or something else. Could be just a skeleton, almost empty, but you have a sort of a starting point. And after that, the API only allows you to send changes, small edits that are being made, typically as a user hops around the user interface, but it doesn't have to be a web UI. It could be any sort of other change as well. And the system sequences those, makes sure what comes first, and emits event out the other end on an event stream, which then other systems can subscribe to again to act and do something with what is being changed. And only at the very end, when you say, okay, I want to send this document, then we wrap it all up and say, well, this is the final invoice, because at least for invoices, legally, after you've sent that, you're not really supposed to change it anymore because there are legal effects that start when you send an invoice. So if you had to write a user interface for an invoice or an order or any kind of structured document, the structure that our current editors typically follow is that, well, we start out with XML. Well, nobody likes XML, so what any good front-ender does is they turn it into JSON first. Then you read that into your JavaScript application, and then the JSON, which becomes a JavaScript object, isn't quite what you can work with in your UI, because you still have all the baggage and all the names of all the XML. So probably some transformations go on there to have an object tree that you can actually put into React or Redux or whatever it is that you're using, and then or jQuery, and then you render your user interface. Then if something changed in the user interface, then here it starts to differ a little bit, but if you follow the same route back, you would update your custom in-browser JavaScript object tree, turn it back into the JSON that you then send into an API that then hopefully turns that back into the XML it came from, and then if everything went well, you're lucky you didn't lose anything on the way. That kind of works. It's how our editors and other editors currently work. But it's a little wasteful, and the big problem is that if you want two users to interact with the same document, then you have to start to be really careful, because if I'm trying to send a new document version and the other one is also sending one, then I could send a WebSocket back and say, well, hold off on that, the other person is also editing. You could probably make that work, but it gets worse and worse as the document grows, because you're sending these big chunks back and forth. And that's not to speak about all these lightning bolt symbols there, which is where the bugs occur. Because this can only work if you know that you get 100% of the XML into your JSON and back again. But think back about the attachment case, like the base64 stuff. The user interface probably isn't interested in that. So are you going to keep that out of the JSON? Maybe. But then the other part here that puts it back has to remember to put it back in from the original XML or start gluing stuff together. It becomes a mess real quickly. So a different way to do it is to think, well, what is the editor actually going to do? It needs to render a user interface based on what's happening to a document. And what's happening to a document, we just formulate it as saying, well, that's a stream of events that's happening. So why not say, okay, that's our data model. We get a stream of edits, in this case, into our user interface. We somehow transform that using a fold-like function into a UI representation. And let's say that's our UI. So that's one half of the equation, right? Now our data model is just edits into user interface elements. So what do we do if we change stuff? Well, we happen to have a data structure that formulates this change. It's called an edit. So let's have the application emit edits back as well and say, well, what rolls out of it are the same edits. The only thing that's lacking is, well, at some point we have to end up with XML again, because we still want to send an invoice to the other end. So there is some work, either in the UI or on the back end, required to fold it back into an XML document. But by only dealing with one data structure in the web browser, we now have a couple of things that we can get for free. Because it doesn't really matter whether these edits are the ones we just emitted and we just want to render because you do want to see what you're doing while you're typing. It could also be the edits coming in from another user. Because the edit just says, okay, change invoice line 10 to have this description, and it doesn't really matter who did that. So the multi-user editing you get for free. But there's actually another thing you can also do, and that use case actually only materialized later on, which is that the one requirement that we have is that for certain countries, for most countries actually, the invoice total has to be the actual proper total of all lines added up using some very special rules that are different for every country. And that has to always hold. And well, right now we have some APIs that help out with that. It's kind of duplicated code all over the place. And we would very much like to be able to automate those totals always being correct. So what we actually allow users to do now is to plug in an extra system component into this flow that can contribute additional data based on the edits that are being made, or actually based on the original document as well. And we called it an augmenter. And what that is allowed to do is whenever you change, say, invoice lines or the totals, it can give one edit and say, hey, please apply this into the actual document as well. And user interface can just treat it as an edit because it's the same data structure, but it's system generated rather than user generated. And again, you don't have to do anything special in the editor to support that because it's the same data structure. It has a different name, there's a little bit of code for it, but the functionality is the same because now you can write a plugin that calculates these totals, and as you're editing the invoice, the totals are just updated. It's just that there is no code in the UI to do that. It is done by a backend component that is plugged into the same flow. And of course, yes, it makes it slower and there's latency and other things. It can be solved. You can also have it in the UI. But by having it as a backend component, you now have to guarantee that all documents in your account get that same treatment. And I've not mentioned this, but most bigger customers on Tradeshift don't type all of their invoices into the UI. They have their own ERP systems that they already work with, and their API integrations that send those whole documents in. But now, for no matter how this document ends up in Tradeshift, we can guarantee certain invariants that will always hold, like the totals matching, like the receiver having the proper credentials, like the invoice is always in euros, or some other things. Validations actually follow a similar flow. I think I'll skip over this for now and go to a part of the demo first. So this picture goes a little bit deeper into the structure I was describing. So what we have is the new document pipeline on Tradeshift, where, say, let's imagine that the document exists there. And then there are two other backend systems that we imagine being written either by another Tradeshift team or even a third party. So anybody should be able to write an editor component. Anybody should be able to write an augmenter that plugs into that account and changes, in this case, the totals. Both of these are connected to an event stream. So whenever documents change on the account where they're installed, the editor does stuff and the augmenter is able to do stuff. In case of the editor, what it will do is, as documents change, it will look at, well, do I have any users that are viewing this document? And if they are, it will send that event down a WebSocket that is connected to that web browser. And similarly, as edits come in, it just passes them on directly to the backend system to say, well, hey, this is being edited by this user. Please store that and make sure that it's a valid edit, which in turn then makes it appear on the event stream. The responsibility of the augmenter is similar. It listens to the event stream, but whenever a document is being edited there, it actually calls back and say, oh, please update the totals for this document. It's now that. And that's a continuous real-time set of callbacks that's happening. So as a result of this seeing an event, there's a callback to the backend system with new totals information. Any questions about this? Okay. Yeah.
Do you do like optimistic rendering on that it's within the client?
Yeah. We do. At least we intend to. I'm not sure what the version is I'm going to demo to you, but that is a fairly obvious optimization you can put in, where in that picture here, the editor is the data structure that you base your UI representation on is the actual edits. In reality, you'll typically see that you'll have an edit and then a little bit of metadata around that, particularly, hey, did I, basically it boils down to, has the server confirmed this edit or not? It's a little bit like, I'm not sure if any use Slack or a similar communication medium that uses a web browser. If you hack some message in and you press enter and you're not connected, it'll typically show grayish or something else. That's a similar state you can introduce here for, hey, I've been typing this, and I think that these edits I'm going to see any moment now on the event stream. I just haven't seen them yet, so I don't know, maybe we're not connected, maybe there's some delay, but I expect to see them. And the expect to see them, you can just make a bit, and you can get that all the way down to a UI layer and then pick a different CSS class to render it gray or something. So I have an editor open here, which, if it loads, should show us an invoice for 3 items that can be purchased. And there's a total that's currently here. Let me try and change some lines here. Just make this to 40, and the total is being updated. Maybe a little more interesting if we can get my terminal here to. I'm doing some real time. How do I get the? Yep. So let's keep editing this. There should be a little bit of interesting stuff scrolling around that's seeing, okay, I'm seeing some events here. This field was being edited. Now the value is this. And I'm going to send back a total that is this $1,312. So what you're seeing here is the augmenter component that sees the event stream of the web browser and calling back, which the editor then picks up and renders again. So again, this editor does know nothing about totals. All it does is it sees events of changes that happen to a document and renders that into a UI. And it doesn't even know that the change, rather it doesn't treat the change of totals differently than any other edits that come in. Another thing I could try and show is if we copy the URL of this editor for a moment and then open another window. This always goes wrong. We should be able to see the same invoice here. So if I start making some changes here, you'll notice that the other browser window also updates with whatever it is that I'm doing. Because again, they're both connected to similar event streams. They both get the same information. They effectively, because they're running the same code, they will always end up in the same state. And it's only the backend that sends the same information to them both.
But normally, okay, the events are things that have happened. Normally you have actions that need to be validated before being turned into events. So especially in this case, that two people are editing the same field at the same moment, there will be some feedback about that?
So the question is that, hey, what about validations of the actions? What about the difference between an action and an event? It's a good point. So if we go back to the slides for a moment. So the API for incoming edits does have some validation on it, but that's a structural validation. That is just, hey, because the data format, which I skipped over, allows you to specify XML tags and parts of a data structure that is valid in a certain context. And there's some validation that says, okay, an invoice line always has to have an ID. So you're not allowed to create a new line without an ID, even if you're going to fill it in later. So those sort of things we'll call an API failure here. However, those are expected to be programmer failures. Like the UI is supposed to not send stuff that way. If it does, it won't break anything on the back end, but the UI will be stuck in a strange state. Other validations are semantic validations, like, hey, this customer only accepts invoices below $1,000, or each invoice line has to be the same currency. Those things, this system doesn't check at all. However, we have a different concept for that called a validator API. It works in a similar way as the augmenter, except its callback isn't edits, its callback is validation errors. And that way you can implement these semantic things. And again, because the validation errors go into the event stream, they can show up in an editor and then you can do the right thing if you make the red boxes. As for the action versus event question, they're called the same in this picture, but you can 100% say that the arrows going to the right are the events because they have happened, and the edits going to the left that are still about to reach the backend. You have to consider actions. That's also why if you loop them back into yourself and render them gray, you don't really know whether they're going to work, right? I don't know, maybe your UI version is lagging behind and the server decided to be more strict or who knows what. Until the server has confirmed them, they're actions. They're stuff the user wants to do. It's not stuff that has already happened. Any other questions? At the same time. How about you first?
What if there's concurrent edits for the document?
Right, yeah, sorry, that you did mention that as well. Yes, so the question is, what about concurrent edits to the same document? Well, concurrent edits to the same document, you just saw that should work just fine. If you edit the same field concurrently, I'm not sure I can show it because I'm only one. I did at some point to test this, back at Tradeshift, get a room of 20 people to try and hack into one document. And the thing is, because I haven't told you much about the backend system. Let's go into that because that is what is solving this. The short answer is that it's undefined, but the system will make up one state and everybody will see the same a little bit like Google Docs, except it's not, because Google Docs, I think, use an actual CRDT, a conflict-free replicated data type. We don't. We just do actors on the server. So this backend system is built using Akka, and there is actually one actor per document. And each of your changes is it goes to a cluster of machines, and Akka guarantees that only one machine in that cluster is running an actor for each document. And that is basically the one that, because it's an actor, Akka will guarantee that it will only see one edit after the other. And well, that way at least you get the same outcome to all users. It doesn't solve conflicts at all. They will still override each other in the same field. What I tend to say about that is that's not a use case you should be solving, right? If two people are trying to edit the same field, and I think Google Docs doesn't allow you to do that either. I think it kind of locks it out. You should, at the very least, you should see the cursor of the other person and sort of prevent them from doing that, because, you know, I don't want to write a CRDT just to allow this to have a sensible outcome. I'd rather just make sure that it kind of works, and then, you know, it kind of goes into the, well, don't do that category. As in, let the UI people come up with the right metaphor to deal with that, because you don't want to be fighting over the, well, maybe you want to fight over the price of your invoice line in this case, but maybe not in this way. And any other questions? There was one more here. No? Okay. Okay, I have time to show you a little bit of source code. So as I mentioned, the source code of this is written in ScalaJS. Actually, part of it is because there's a backend part and a front-end part, but then the nice thing is that with ScalaJS, you can share code between the backend and the front-end. Just wondering, who of you have never used ScalaJS before? Okay. I can show you what it looks like. There's some script here that, what does it do again? Sets up an XML HTTP request and gets some tweets from Twitter. But I keep forgetting whether this is JavaScript or Scala code, because it's actually the same except for the one little type signature you see there on the event. Even with ECMAScript 6, you get the arrow function and everything else. I don't know where they got that idea to do that, but when I meet some frontenders and they're in the scared of Scala programmer category, which fortunately quite a few colleagues out there are, I tend to show them these things, and there's actually a great comparison on the ScalaJS website of, hey, this is how you do stuff in ECMAScript 6, and this is what it looks like in Scala, and it's actually, you know, it's not that different. It's not complicated to work with. So ScalaJS is a cross-compiler that takes Scala code, raw Scala code, and turns that directly into JavaScript that can run in your web browser or Node.js. And because it's tied directly to the Scala compiler, it supports everything that Scala 2.12 can do. So including macros, type classes, implicits, the whole shebang. What it does not do 100% is the JVM standard library, because that's big. However, because it does 100% of the Scala language, actually you can use all of, or how do you say? Well, yes, you can use all of the code that was written in Scala, and that doesn't touch on the JVM library that much. And that means that most things from unit test libraries to CLDR data for internationalization to validation frameworks and other stuff, even Akka and Akka streams can be cross-compiled to ScalaJS and run in the web browser. I have not tried that last part yet. Maybe a bit of overkill, but you can do it. And there's a guy very happy that he was able to pull that off. It's JavaScript code that it generates is pretty big, but small enough that it kind of just works, right? It's a megabyte or so overhead plus what you're actually writing, which it's good enough for a web browser, especially after you've loaded once. I haven't personally tested it on mobile. I don't know how well that would work. And that is something that I would say may require a bit of work yet. One of the nice parts that I feel is that it really is just a compiler. I'm not sure, have you remember GWT, the Google Web Toolkit? from back in the day. There was sort of a similar approach of saying, well, let's use a decent language to write something for the web browser. But they went a little bit further and said, well, yeah, there's this, and then we have this protobuf-based Google, what's it called? The Google RPC stuff that you can write your services with, and and you can have this in, and yeah, by the way, if you want to call native JavaScript code, you just write it in a Java comment, because that makes sense. And yeah, it sort of didn't quite work, and partly because of features of the Scala compiler, ScalaJS took a lot nicer decisions. Okay, let's go into a little bit of code. So the actually, let's go a little bit back up. So what I've opened here is the editor project itself, which, by the way, we're going to open source all of the non-Tradeshift stuff, but we want to do this in a nice way with documentation and other things. That's not quite there, but this structure will be linked to by our documentation. I'll talk a little bit about some code anyways. Can you guys hear me in the back still? Okay, cool. So there's still some intermediate state in this editor architecture, and there are two reasons we decided on that. One is that it just makes things a bit cleaner. But a more important one is that it allows unit testability of things. So our intermediate invoice representation, which you see here, is just a plain case class with an ID, some lines, a global currency code, and a total that wraps sort of the total aspect that you saw in the editor. And this is in a common project that is shared by the backend and the frontend. And what you can do here is there's a method that takes in an edit structure. So UBL document edit is the data structure that we dreamt up to cover changes being made to a document. So that contains stuff like, hey, the description of invoice line 20 is changed to this, or the price of invoice line 40 is that. And if you ever used XPath or a similar thing for JavaScript, its structure is similar to that, but we kept it extremely limited on purpose because this is exposed on an API, and everybody with a little bit of functional, or how do you say, the experience of implementing a fold function should be able to apply this to a tree and create a user interface from it. So we didn't want to go full XPath on that. So what this method does is it will take one of these edits and spit out a new invoice with that edit applied. Since edits can have multiple changes, this just folds into a different consume method that actually takes a change, which is here. And now one of the nice things about Scala shows itself immediately. The UBL specification in its lowest level defines data types for all the scalar values you could have in a document. And those data types are more rich than XSD defines, so it's not just a number or text. You have to say whether your number is a measurement with a unit in meters or kilograms, or maybe the number is a GPS coordinate, part of some things, or the number is an amount with a currency, and then you have to have a currency. So it's sort of a little bit richer than int and string. And that's the level that we chose to hook into for the generic parts of the whole pipeline. So the custom data types that you can write also have to use that slightly higher level, because it's rare that you have a document you say, well, this is an int. Usually you know more than it's a number and it's an integer number. It was, I don't know, maybe it was a measurement or a total or whatever. I haven't seen raw types in this at all. So what we see here is that we can then look at, okay, what is actually being changed and what type of data type is it that is being changed. For example, here, well, hey, if there is a document currency code tag with a value that's being changed, then let's extract that into currency code, where you can see in my, you almost can't read it, but Emacs tells me this is a string. And, well, then we just change our currency code to be that. And that small line will now grab something that is trying to change the currency code tag on the root. So we happen to have the invoice still open here. So there's a currency code thing here somewhere called there, document currency code. So whatever is dropped into here, but then in that edit, will be applied, and we remember that as the currency code. Now, not all tags sit on the root. There are some other tags that have children themselves called aggregate tags. In this case, invoice lines. So we're going to go to them here, where inside an invoice line we have an ID and quantity and other stuff, which is reflected here again, where inside this invoice line, if we're trying to edit or remove lines, we can go further into those data types and apply those changes. The relation stuff here, that is part of the data structure of applying an edit, where you can't just say, or you can't only say, please edit invoice line 10. You can also say, please add something after invoice line 10. Since in the edit, of course, at some point you need to be able to add invoice lines or split them up or do other things to it, where you have to be a bit more precise. Okay, where is this line with respect to the others? I think that's all the time I have for the code part. So, are there any questions? Anything in particular you'd like to see? I should mention that for the front-end side, we're extremely happy with a framework called Outwatch. If you're doing any kind of ScalaJS at all, and you're looking for a reactive, nice approach to sort of deal with these kinds of event-based systems, but also something that resembles the Redux architecture or Elm, Outwatch is really one of the nicer frameworks that I found out there. Yes. So the question is there reuse between the server and the browser? This precise class invoice is actually shared. So it's cross-compiled. It runs on the server and on the browser. One reason for that is that although ScalaJS cross-compiles to JavaScript, which runs in the browser, it is for some things about 100 times faster to run it on the JVM and allow all the optimizations there. Especially if you think about documents in this style, you have an edit and an edit and an edit and an edit and an edit, and you very quickly have hundreds or thousands of these edits. And that's something that, of course, you can optimize again. You can create some snapshots and go from there, but we're not optimizing that right now, because if we transform our UBL document edits and read them in from the backend through this invoice class and run this reduce function on the server, it will wrap up 100 events in about 10 milliseconds, and it sort of scales from there. So it's not really noticeable that it happens. But if we try and do the same thing in the front end, it takes seconds or more. And I suspect part of that is the protobuf library that we're using, which generates, let's say, some Scala code I wouldn't write myself. And there are better ways to deal with that, because there are much faster protobuf parsing libraries in native JavaScript. But for the moment, we do that on the server, and we have an API that says, hey, give me the invoice representation at event 500. And that just goes into the front end, and it just then runs the code from here. So that's why the same code runs on the server and on the client. Yeah. So I think this is where I wrap up. If you get the slides, there's some links to our APIs if you actually want to play with this or try some other language to connect to that. We're also hiring, so if you are interested in this subject matter or in Scala or ScalaJS at all, or writing big systems that need to run all over the world, either find us online or send me a link, send me a line. Any final questions? Sure. So the question is, are there any challenges I faced in ScalaJS versus plain Scala? Do you mean technological challenges, or could you give an example? Right. Yes. So we did consider alternatives. Actually, I looked at React and Redux and TypeScript. Now, this was a while back, so not all of this may hold today. And I would also say, if you bring anything home from my talk, think about the architectural styles, not just the language itself. But when I looked at it, I think neither React nor Redux is nor the how do you say, the streaming frameworks are actually written in TypeScript. So you have sort of this type safety halfway. Then with protobuf, so our event definitions are written in protobuf. There's JavaScript support for protobuf, but again, then you get a plain JavaScript object, so you don't really get the type safety there either. So it would require a lot of additional work to make that actually sort of halfway safe. Then at some point we did actually write a plain JavaScript approach, and although that works, I mean, you can, again, since the JavaScript, the good parts book and ECMAScript 6 and everything, you can write fairly decent JavaScript code, but the matching part, what you just saw, that case class matching block, if you don't have pattern matches in your language, that is just a complete dragon to write. It's no fun at all. One thing that comes close, especially these days, because they have a protobuf generator, I think, is Elm, which any of you may actually look into, because I think it's a Haskell derivative. I don't know Haskell, so I don't know what I'm saying. But it is a very nicely structured way to write front-end applications. But they still don't have server-side reuse, so there's some limitations there as well. Anyway, so there are some alternatives that you could consider. Thanks, guys.